designs. Like I said, today we're going to start a preliminary hazard analysis. It's called preliminary because it's the beginning, okay? It's something you do at the start. You're gonna have what you call preliminary hazard analysis, and you're gonna have what you call detailed hazard analysis. Detailed hazard analysis means you go in depth, okay? You use different techniques. You look for a more rigorous approach to finding the root cause of the problem, okay? Or identifying the solutions to the problem. So that's called detailed hazard analysis. As for preliminary hazard analysis, it's simple and usually the first step. Okay, so it's an inductive method. Inductive means investigation, okay? It doesn't go deep, but it investigates the problem at hand. The objective is to identify hazards and hazardous situations that can cause events of harm for a given activity, facility, or system. So basically, PHE is just like it helps you to identify all potential hazards in the workplace. Now, this is different from what or let's go on. PHE is preliminary or initial. Okay, usually do it at the beginning of the design of a system or facility. Now, PHE by safety professionals to identify hazards, as we said, that's what it's basically used for. And the necessary control measures, okay, that is true. And allow for the risk levels to be prioritized for further risk assessment and management. That is 3. Okay. So you can see it has 3 main objectives. 1 is to identify hazards. Okay. 2, control measures. And 3, allow for risk levels to be changed and also to be prioritized, and then the risk controls will be applied and the risk will be brought further down and things like that. So its primary purpose to identify and describe significant hazards that might arise from defects, safe actions, conditions in design and operation of a system. So if you have a system or you have a machine or equipment that is being used, or you sense that there's some defects in the system, there's some problems in the system, this is the potential source of risk. Okay. So here it says it is especially useful in providing an atmosphere of current state risk levels and the risk reduction levels of proposed industries. Okay. So for example, we want to know what is the risk level, risk assessment of another company, what is the risk assessment, and what evaluation are they using? What kind of treatments are they using? What kind of reduction methods are they using? All right. This is determine how they are able to bring down the risks. Now, pitch can lead to is something that is simple. I said it's simple and inductive, and can be the first stage to a more detailed hazard analysis, such as FMEA, failure modes and effect analysis, FEMICA, and fault tree analysis. Okay, these are just some of them, some of the methods that you can use. Okay, FMEA. Now, these methods are commonly used to further identify, evaluate, to avoid hazards in more complex or safety design. Okay, so they use these methods after PHA to further the approach to investigate more and to see what are the issues surrounding the risk. Now, these methods are commonly used to further, as we said. Now, PHA should be updated as necessary during phase of design, construction, and testing. Okay, just like every hazard analysis method that we talked about, usually you have to continue to update. You have to continue hazard is not a static process, it's a dynamic process, which means that you have to continue to check, you have to update, you have to continue to check, you have to update what's happening in your laboratory, all right, or what's happening in your analysis or your research or things like that. You have to keep investigating and keep updating new information. Now, PHA should be updated as necessary during phases of design, construction, and detecting to detect and testing to detect any new hazards and controls needed. Now, PHA stands for, there's different type of PHA. This one is called process safety, okay, or process hazard analysis. So it's different from preliminary hazard analysis, okay. So the first PHA, preliminary hazard analysis, is a risk assessment method, as we have been discussing. When it comes to PHA, it's a different topic. PHA is for those that study chemical, okay, those that study chemicals or hazardous materials and things like that. You have to do a PHA anytime there's an emergency. So PHA needs stands for the process of hazard analysis in the OSHA. That's in OSHA's document. All right. In EPA risk management program for conducting chemical accidental release prevention engineers. Okay. So basically, you can see we have PHA, we have PSA. PSA means for process safety. PHA means for various type of hazards, construction, chemical, oil and gas, everything like that. Or PSA, which is PHA, which is process hazard analysis. This has to do with only chemical process industries and chemical industries. And the process tests for preliminary hazard analysis are similar to other hazard analysis, as we discussed previously. Okay, first of all, you establish the context of the risk assessment. Explain to you. Sorry about that. Explain to you that context could be what the purpose of the risk assessment, the objectives, okay, risk matrix, okay, and all that can fall under defining the purpose of the risk assessment. Next, you get your PHA team. What are those that's going to work with you? Okay, these should be people that have experience in the area. Okay, they must have some level of experience in the area to form part of your team. Okay, so they can advise you on what are the issues you need to look out for, what are this and that. Okay. Also, you might have a list of hazards after developing your team. The total list of the potential hazards in the site or the system or the process or the workplace. Okay, and then next you do what? You develop a PHA worksheet. Now, this worksheet is basically like a template where you just fill in the information that you have. So estimate current state of severity. Once you've done that, you can estimate what is the state of severity now without any control. Okay, and then after that, the current state of what? Likelihood. Yeah, without any controls, anything, just the current state of likelihood, and then the current state of the what do you call it? Current state of likelihood, current state of risk level. Right. The current state of risk level comes from both combining the severity and the likelihood, as you already know, that the risk level is equal to severity multiplied by, okay, yeah, you have risk level equals to severity multiplied by likelihood. All right. So basically, after identifying the current state, then you have to identify what are the risk controls that are available on site. Okay, that's the existing risk control. Based on the existing risk control, you can bring the risk level even further. So even come down. All right, and based on that, you can carry out the risk assessment for the future state. Okay, for the future state, so that's our current state. For the future state of severity, likelihood, and risk levels, and then you calculate the risk level after you get it. You have you have risk level equals to, let me see, severity multiplied by likelihood times you have the prevention effectiveness. All right, prevention effectiveness. So some prevention methods might be more effective than others. I believe we already explained some of all these things. One looked at in the previous lectures. So you estimate the future level of the risk for likelihood, risk levels. If it is okay, then that's it. If it's not okay, you have to go back again and carry out the risk assessments for this particular risk. So this is a template here. You can also see very similar to this is a preliminary hazard analysis. You can see here that you have firstly, you have apart from the IDs, you have also the hazard description. This one. After that, you have exposure description. Okay, how can people get exposed to these hazards? Next, talk about exposed assets. That's property that might be exposed to these hazards. Okay, I have elevated controls. You have the severity is 5. Okay, and the likelihood is 3. This gives us 15. And this one, the severity is 2. Likelihood is 2. Give us 18. So this gives us 8. Now, what about the proposed controls? Proposed controls are also made in different categories like engineering controls, warming, admin, and PPs. There could be other levels of controls that might be applicable, like substitution, avoidance. If it is applicable to this hazard, then we have to look for strategies on which we can apply that solution to that hazard. Otherwise, we leave as it is. Similarly, you can say also for thermal expansion, which is an engineering problem. The risk is what? Is orange. That is 12. All right. And then to try to reduce it, we have various strategies: engineering, warning, admin, and I gave you guys 4. All right, 4 by 1, it is 4. Lastly, we have corrosion, which is also a significant hazard. However, in this particular study, it's the likelihood is high, the severity is high, but the likelihood is low. Okay, in Saudi Arabia, I'll say the likelihood is somehow high. Why? Because we have a salty environment. But for this particular study that they use in the textbook, likelihood is considered low, that is 2, and 4 by 2 is 8. So they try to reduce the risk further by putting in place some controls. Now, according to the controls, they have engineering and they have admin controls. Under engineering, they have a list. Under admin, they have also a list. So based on that, they decided that the severity is less than 4, and the new likelihood will now be 1. Okay, and this will determine that this is the risk assessment, the whole entire risk assessment. So you can see also the color coding. Anything that is between 15 and 20 or 25 is red, that is dark red. Anything that is between 11 and 15, takriban, is orange. Anything that is between probably 5 and 10 is yellow. Anything less than that is considered as 1. Okay, so this is how we can see the color coding and can know what kind of risk is accepted as in based on the level of controls available and what kind of risk is not accepted. Okay, because it is too high and the consequences are too high. So in process of page A, you have to set a set of systematic assessments of the potential hazards as stated in the industrial area. So page A, identify these potential causes and consequences from things like fires, explosions, analysis of toxic or flammable chemicals and dispersion, and focuses on equipment, instrumentation, utilities, human actions, and external factors that may impact the process. Also, in many cases, additional benefit of conducting such analysis is a more thorough understanding. Okay, this gives you a better understanding of the system, of the process, okay, of the industrial process. The fact that you're carrying out a risk assessment of the system will make you understand the system better. And this leads towards leading to opportunities for improving the process efficiency and loss reduction. Okay. So here also, let's look at what OSHA has to say and also what EPA has to say. Now for OSHA, where we talk about process safety management, PSM, different from process safety, preliminary hazard analysis, as you remember. We have preliminary hazard analysis and we have process hazard analysis. So for process analysis, what we call the PSM, process safety management, and this is meant for highly hazardous materials. Okay, for example, any kind of facility that has more than 10,000 pounds, okay, of more hazardous materials, they have to notify the community. All right, you have to when you have more than 10,000 pounds or more of hazardous chemicals, you have to inform the community. You have to inform OSHA, for example. All right. Also, you have to inform the community where you are living. There are people that are living around where your plant is. They need to know what is in this plant. There's an accident, similar accident that happened in the United States of a factory or a fertilizer factory. They make fertilizers in this factory, but don't forget that fertilizers are highly explosive materials. So they had this huge amount of material they were using without telling the people living around that area that they have this huge number of materials living in their facility. It led to a terrible explosion that spread to many houses around this facility. Something else is the EPA, the Chemical Accident Prevention Program, that's the RMP, established in 1994 or issued in 1994 as a result of Clean Air Act. So OSHA process safety management requirements for process hazard analysis in regulated facilities for the purpose of protecting the public and environment from undesired consequences of explosions and energy. So here for EPA, they have just general, all right, they just have general statements regarding the process safety management and organizations be more responsible in how to manage their processes and the chemicals or the materials that they use and things like that. As for OSHA, OSHA gives a strict regulation in terms of how much material can a company keep at one point in time. And they put the limit at 10,000 pounds, which means that if it's more than 10,000 pounds, then definitely it's going to be what they're going to be arrested or fined or given a violation or citation or things like that. So that brings us to the end of the second lecture on risk analysis. Okay. There are other types of risk analysis, but let's see. Hopefully, we can discuss some of them. We have talked about MECA. We have talked about HAZOP. We have talked about MECA, HAZOP. What else? Brainstorming, what if analysis. We talked about SWIFT, that is structured what if analysis. So basically, also we talked about PHA, preliminary hazard analysis. So basically, we'll look at examples also of these various risk assessment methods, probably in the next class. And they're expecting something in the exam, okay, of any of these risk assessment methods. They're expecting a very small example that you have to do in the exam. But I'll show you the example in the classroom. I'll show you example, work the example in the classroom. And then after that, also, you have to prepare for this in the exam. All right, Shabab, at this point, do you have any questions?